We've already said that the routers within an area need to share the same database. As a result, they need to exchange information between one another. However, consider a collection of routers like we have here that are connected to a common subnet. Maybe they're all connected to the same Cisco catalyst switch like we have pictured here. And since they all have interfaces on the same subnet, instead of forming a full adjacency, we can use something called a designated router, or a DR, and a backup designated router, or a BDR. You see, this doesn't scale very well if we wanted to have a full mesh of adjacencies between all of these routers. The number of adjacencies to have every router adjacent to every other router can be determined by this formula, n times n minus 1, and take that product and divide by 2, where n is the number of routers. Just as a very basic example, I've placed 6 routers on screen. 6 times 6 minus 1, 6 times 5 is 30, divided by 2 is 15. Here we have those 15 different adjacencies that we would have to form, and that's with only 6 routers. If we had 10 routers, that would be 10 times 9 divided by 2. That would be 45 adjacencies. Well, since all of these routers have interfaces on the same subnet, on the same network segment, instead of having this full mesh, it's almost a full mess of adjacencies, what we can do is elect a designated router, a DR, and as a backup, we can have a BDR, a backup designated router. And that way, these routers only need to form adjacencies with the DR and the BDR. This is going to help things to scale more. And this is with only 6 routers on the same subnet. The number of adjacencies increases quite a bit as we start to increase routers. So here, we're going to have an adjacency formed between the designated router and all of the other routers, and the backup designated router and all of the other routers. This can dramatically reduce the number of adjacencies that we have to have on a broadcast medium like a gigabit Ethernet network, as an example. Keep in mind that we might have a network that's just a point-to-point link between 2 routers running the point-to-point protocol, or HDLC, or something like that. In that case, we would not need a designated router. In fact, there are different OSPF network types that we're going to be talking about, and some of them use a designated router and some of them do not. But the classic example that we normally think of when we think of a network that is going to be using a designated router, it's some sort of an Ethernet network like we have here. Now that we understand the concept and the benefit of a DR, a designated router, let's see how a designated router is selected. Remember the hello protocol? Well, it's the hello protocol that's going to be used for this election. And as these routers are vying to become the designated router, the router with the highest OSPF priority value wins. An OSPF priority value is associated with an interface that's participating in OSPF, and that value can be as low as 0, or it can be as high as 255. A 0, though, has a special meaning. If we have an interface with an OSPF priority value of 0, that means that that router that includes that interface, that router is not going to become the designated router for that network segment. By default, an interface has an OSPF priority value of a 1, and we can go in if we want to administratively influence who's going to become the designated router and who's going to become the second best, the backup designated router. We could go in to interface configuration mode and use the IP OSPF priority command followed by a value. We would need to give a value in the range of 0 through 255, and we could specify a 0 there if we did not want this router to become the designated router, or we could give it a high value if we did want it to become the DR. But what if we just connect our routers and everybody has the default OSPF priority and everything's a tie? Who wins in the event of a tie? Well, if the priorities tie, it's the router that has the highest router ID that becomes the DR. What is the router ID? We can administratively configure the router ID in router configuration mode with the command router-ID followed by an ID. But if it's not configured, we're going to take the highest IP address of a loopback interface that's up and operational on this router. Let's say it's 1.1.1.1. We've assigned that to a loopback interface. Well, if that's the highest IP address on a loopback interface, maybe we only have one loopback interface, that's going to become this router's router ID. Oh, and by the way, please don't be concerned if we assign an IP address like 1.1.1.1 or 2.2.2.2 to our loopback interfaces. Many administrators do that just to make it an easy to remember number for a router's router ID. We don't have to advertise that network out. You might say, 1.1.1.1, that's public IP address space. That's not private IP address space. I cannot route that. That belongs to somebody else. Well, you could use that IP address just for your own convenience. You don't have to advertise it out. It doesn't even have to be reachable by your neighboring router. You can assign an IP address like that to a loopback interface for the sole purpose of setting your router ID, or, again, if you prefer, you could do it in router configuration mode. What if we don't have a loopback interface, though? Well, in that case, we're going to take a look at the interfaces that are currently up and operational on the router, and whichever interface has the highest IP address of the non-loopback interfaces that are up, that's going to become the router ID. And this is the way that a DR election plays out. However, the question sometimes comes up, what if a router gets added to this topology and it has a higher priority? Is it going to take over? Is it going to usurp authority and say, I'm the DR? No, after the election has finished, unless there's something else that triggers another election, the addition of another router with a higher OSPF priority, that's not going to cause it to preempt the existing designated router.